I'm sure you've seen plenty of Vision AI at the Edge demos, where you see these smart cameras that detect people in a room. What you're not seeing very often is how these models are trained and optimized for specific scenarios and then to run on specific type of hardware. One of these tools is called EdgeFirst AI by Ozone. And today on the IoT Show, I have Muid from Ozone to tell us everything you need to know about EdgeFirst AI and what are the complexity you're going to face when you want to train Vision AI models to run in particular scenarios, context, and for a specific purpose. If you like the episode, do not hesitate to like the show, to subscribe to the channel, to get notified when a new episode comes up. Thanks for tuning in. Hi everyone, this is the IoT Show. I'm Olivier, your host. Today we have an interesting topic, which is Vision AI at the edge, and more precisely how complex it is and how a solution like EdgeFirst from Ozone can help you make it easier. And for that, we have Muid on the IoT Show. Thanks for joining us today, Muid. How are you?
You're welcome. I'm fine.
So where are you calling from?
I'm calling from Calgary, Alberta.
Okay, how's the weather today? Fresh?
It's much nicer for this part of the year. February, it's plus 8 today, so good.
Celsius, right? For our friends in the US here. So 8 Celsius is decent. That's a good one. Definitely. So Muid, you are part of Ozone, a company that is based in Canada and that specializes in solutions for vision, or I would say perception of environments, especially in industrial or ruggedized type of environment. So tell me a little bit about yourself first, your background, and then a little bit about Ozone and what you guys are doing.
So I have a PhD in electrical engineering quite a while back, and then my specialization was machine learning at that time. And I tried different fields over the period of time, but I've settled into machine learning, and I've spent about 25 plus years into it. So I have many patents and publications on this topic.
Okay, awesome. So that actually sets the stage for the rest of the conversation. And Ozone, the company you work with, what are you guys doing? I gave a very high level introduction, but I'd like for you to tell me a bit more about Ozone.
Yeah, so Ozone is a group of some dynamic professionals and engineers. And our aim here is to develop an ecosystem for vision-based edge environment so that users and our teams can train, develop models, verify them, and then deploy them on edge devices.
Yeah, and we'll see some of that. We'll see some of the tools. We'll discuss the platform. Things are not trivial, and that's one of the reasons you bring up all that stack of tools and libraries and so on. But why is it so important to solve these problems? What does Vision AI at the edge bring to the table?
So edge has always been a source of interest for engineers, but as the technology has progressed, the edge devices have become more powerful, and the realization for having devices do the processing where the data is generated and be consumed there. So that has prompted the whole edge movement and processing over the edge. So it's important because the data is consumed on the devices. So sometimes there are privacy issues that the data cannot be shared. So it is generated, consumed, and deleted from the device. There are sometimes bandwidth issues that so much data cannot be transported to a central server and processed there. So it can be processed on the device. Latency is another issue, that if the data is transmitted to the server and received back, then the latency of data transfer would delay the results. Sometimes actions have to be taken immediately based upon the data that you receive. And finally, cost, because servers do cost a lot, and if there are big central servers, the cost is an issue. And this deployment over the edge, it scales better. So if you want more horsepower, you can have small devices planted at different places. and it scales without having to rebuild the infrastructure.
Okay, interesting. So let's try and visualize that a little bit. Can you give me a couple of examples of use cases, specifically of the use of vision AI at the edge, right? A few examples.
Yeah, so it has become quite prevalent. So, for example, in auto industries, there are safety systems that detects, like now autonomous cars are very common. Even inside the cars, there are like gesture-based recognition for infotainment system. Those are very common. Then we have autonomous vehicles. Apart from the cars, there could be rescue vehicles, there could be space vehicles. So all those processing for collision avoidance and safety on those vehicles, that is important. Um, Industrial quality inspection over the edge, it is useful because decision can be made immediately on the device without sharing the data outside, again latency issues. Smart agriculture, construction, safety, those are again examples of processing over the edge. And finally, mobile phones, they are a very powerful device, and there are tons of AI processing over there.
These are very interesting, examples. And one thing that people should realize is that vision AI in these scenarios has to be very specialized, right? Because we have seen all these open source models that allow you to detect anything, right? And you have this huge library, and you put that on a device, and you can see a banana, and then a cat, and then a bicycle. But in our case, we're talking about specialized systems. You want low latency, but you also want something that is precise, accurate enough, so that it's not just about, hey, there's 20% chance there's a cat, so I'm just going to run over and we'll be fine, right? Here we're talking about things that have safety implications and so on. How hard is it to go from these open source models, or things that are out there, and go to something that is very specialized when it comes to vision AI? Do you need to be a data scientist? You have a PhD, and people are very smart in that domain. How hard is it to build these models for these specialized solutions?
Yeah, so until quite recently, it was a quite challenging job because AI itself needs specialized knowledge. And also for the vision over the edge, it requires even more specialties, like looking at the constrained resources that edge devices have. However, with the tools that are getting prevalent, for example, the EdgeFirst Studio as an example, uh, they provide a base layer of a lot of work that is already done, and user can simply play with the data and start training and deploying models. So the focus now has become that people with domain knowledge, they should be able to use AI rather than they're constricted with the deep AI knowledge and be hampered with that.
So basically, abstracting the complexity of the technology for allowing someone, for example, who is an expert in robotics or safety in work areas, to create the models for the application, right?
And so, for example, one of our customers, they are expert in ocean debris clean, and they are using models because they don't want to go into coding of the AI systems. So they can train their models. They have collected a huge amount of data, and they work on models without having a deep understanding of how AI works because they are expert in their area.
Yeah. That makes sense. That makes a lot of sense. So, what are, if we want to double click a little bit, we say it's complex, and the domain in the technology is complex per se. Tools like EdgeFirst simplify it for, some domain experts. But what would you say are the biggest challenges that people will face when building, Edge Vision AI?
So, like always, the biggest challenge is the data itself. So, having a library of good data sets is important for a good model to be trained. Collecting huge amount of data and processing it, curating it is a complex job, and that can be eased by using appropriate tools. Then annotation of the data, that has been a big problem because for vision-based application, bulk of the data is like videos, streams of videos, and they have thousands of frames in them. So looking at each frame, identifying objects and annotating them, that's sometime or now has become beyond the capabilities of manual annotation.
Yeah.
So tools are necessary for those, and choosing the right tool is important for annotating huge amount of data. For the edge environment, the constraints of the device, because they are restricted in their bandwidth, they have a power budget. They can't consume a huge amount of wattage. And also their processing power. If they have a CPU, GPU, or NPU, those are the constraints. So training a model is one thing, then optimizing the model for that runtime environment is another challenge. So all that layers of complexities, they keep on adding up to have a sufficiently challenging environment.
Yeah, sufficiently complex. I hear you totally, because what you described rapidly are really key points here. EdgeFirst Studio is one of these tools that make things easier, and that's why I wanted to have you guys here on the IoT show, because there are tools out there that exist that simplify all that process of optimizing the models, specializing them, I would say, or adapting them, and then optimizing them to run at the edge. So I would like for you to take us on a tour. Tell us a little bit about EdgeFirst Studio and how the tool and the platform address these various challenges you just mentioned.
So EdgeFirst Studio is a part of a bigger suite, which is EdgeFirst AI. It has main three components. One is EdgeFirst Studio, and then there is a perception stack, EdgeFirst Perception, that is firmware that can be ported to edge devices and has efficient model runners so that the runtime processing and power consumption are reduced and efficiently can run. And the third is the EdgeFirst platforms that have dedicated and optimized vision pipelines so that the video streams can be captured, processed, and out can be generated. So these three components make the whole EdgeFirst AI a powerful and useful environment where bulk of the work has already been done for the end user, and they have just to plug and play their part of the data set or models and achieve a final working system for them.
I like that. So the way I like to describe what you just described, tell me if that's not the right way of putting it, but I would describe it as a bridge between this world of AI and edge and the world of whatever domain of expertise the final user is in, right? And you're bridging the
Correct.
two worlds with a sufficient level of abstraction of these complexities, still the right set of knobs for them to really be able to adjust things the way they need. And so that's the way I like to describe this kind of tools.
Correct. You put it quite rightly.
Awesome. So you know what? The best thing is to show, right? So we described everything in terms of the complexity of the domain, the challenges, what we're trying to achieve here, and how EdgeFirst Studio can bridge these two worlds. So how about you show us a couple of examples that will talk to people out there?
So the best example would be to go through running a small workflow that would take us from end to end. And then probably after we've done that, we will look into more complex, realistic type of problems. So the first problem, let's say that we would like to train a model, capture some data, annotate it, and train a model, and then be able to run it and see how it performs. So the example that I've chosen for today is a coffee cup, detection of coffee cup, because it's prevalent. You can find it in any office. But the overall process is the same for any other, even more complex type of problem.
Yeah, and you were saying something initially, Muid, is that it's super important to create good models to have good data. And good data, in the case of Vision AI, would be data that resemble as much as possible the environment you'll be in. You were mentioning, the coffee cup, but the environment is super important because when a camera evolves in an environment with a lot of light, whatever, it's a totally different thing than when it evolves in an environment with low light or obstacles. So the more you have data that is the one that is being captured in your environment, the better to create the models that will be efficient, right?
Yeah, so diversity is the key that you would have diverse running environments. So the more diverse your data set is, from the perspective of lighting, from distance of the object, from different angles of the object, different background settings, the better the model would be trained.
Sense.
So what I did that we have some videos already captured and imported into the system. So these are coffee cups with different backgrounds and different settings. And if I were to open any one of them and I play, these are videos that have, and then a hand comes in, which is kind of an obstruction so that it is partly occluded. So what we'll do that we will try to annotate one of them and then we'll start a training on them. So there are different ways of annotating. The easiest or the slowest way would be just to annotate it with a bounding box and then go to the next frame and then put a bounding box there and so on and so forth. This would, of course, be quite slow. So a much faster way would be either keyframe editing or even better, an AI-assisted ground truth generation. So I will trigger a background server that will enable us to process the whole video, and the starting of the server will take some time. So it's estimated 3 minutes. So we'll wait for that.
Yeah, and while it's going through that, you're basically using AI to annotate images to train another AI model, right?
Correct. So there are two ways that the automated AI-assisted annotation is implemented in this tool. One is that you could have at the time of import of the data set, you could have a model that is trained on the object that was already trained on. It could identify it. So those are the prompts that you create. I will create a prompt on this, and then AI will take from those thereon. So those prompts can be created even without myself. An AI model can create a prompt, and then another piece of AI would take it over to annotate the rest of the video. The other is that I could import a video, create a manual prompt, and then submit it to the AI for propagation it throughout the whole video sequence. So now the server has started, and now I will create a manual prompt. And as I do that, it automatically detected. I was a bit more liberal in making the bounding box, but it has made a more realistic tight box around the object and also segmented.
Yeah.
Making bounding boxes is relatively easy manually, but making segmentation mask is much more complex activity. So it has done that. And now all we have to do is this has 89 frames in this video. Then I will click this propagate button. Okay. And when I click that, it is now annotating one frame at a time. And as it is doing, we can preview. It is going from frame 10, 13, 14 onward.
All of this is running in the cloud right now, right?
This is all running in the cloud. Okay. And now all of them are done. And all we have to do is to save AIGT annotations, AI-assisted ground truth. And as now I go to the first frame and I play it again, all the frames are annotated.
Nice.
And you see when the occlusion comes, it awards the hand and then segments the rest of the. So that is the first big part that has been done. So now the next part is to start a trainer on that. And we will annotate all the video sequence likewise. And as you saw, it took less than a minute to do that. So we go here and go to model experiments, and we click on a training session and create a new session. Let's call this demo 1. We pick the coffee cup, although we have to fill the what type of training group, but since there was only one training group and one validation group, it pre-selected those. We can select the type of the resolution that it would work on, what type of backbone is required, model type, small, medium, large, we'll choose large. If we want object detection, segmentation, or both, we'll choose both. Number of epochs, I think 50 is sufficient for this simplistic kind of activity, and we will start a training session. Now, this training session, this card indicates that a training session has been triggered, and this is running on the cloud in the background. So a special server has been initiated for this job alone. Now, if I go to any other page, do anything else, I can trigger multiple sessions simultaneously. And if I come back to it, they all will be running. And after initialization, the progress will be shown here. And finally, when it has completed, it will give me the message that it has completed the training. So the beauty here is that I can quickly generate another one with different parameters, whichever I choose to, and trigger different trainings. And all those trainings will be initiated here. Let's start another one, demo 2.
So typically the scenario would be, for example, to have a different camera with a different resolution, and you want to implement the model on that other camera. Could that be a scenario for running a second training session?
Correct. Sometimes we want to try different backbones. Sometimes we want to see the input resolution changes, and we could play with data augmentation parameters and so on. So as we create another one, a new card will be generated, and it will be this. I can have maybe 10, 15, as many type of experiments that I want to run in parallel. And then I can compare which one has the best results, and I can keep that, or I can further refine the one that is giving me better results and delete the rest of them. So save a lot of time.
You parallelize the work of generating these different or training these different models with different parameters to then evaluate which one is the best. There's a cost incurred, right? We'll not talk about details about that, but people need to realize that, well, you're leveraging a cloud service here. So you can span out different training sessions, but there is compute that is happening in the back. So you have to be conscious of that, right?
Yes. However, these are simplistic models, and I will go to some pre-trained, coffee cup pre-trained, and they've taken less than an hour of training.
Okay.
And then I'll show you that there are models that have taken 6-7 days to train. So if you have multiple sessions of 6-7 days, of course, that would be higher cost. But 6-7 sessions of half an hour training, that would not be that huge of a cost.
Yep.
So let's get into some of the coffee cup models that we have already trained, and see how they perform and how they are working. So I go to coffee cup, and as you see, we've trained with many different scenarios. Some we thought are not good enough, and so we aborted the ones that we didn't like.
Okay.
And let me try one of them. So
Yeah.
it is one of the models. So the one advantage that we have here that I have the liberty to run these models on an edge device that is very common to everyone, which is cell phone.
Yeah.
Or you can run it on your PC. So at this moment, I will be running on my PC.
Okay.
So since this is fully trained, I have this run model facility available here. Either I can select images from some pre-selected images, and it did a good job on that.
Yeah.
But more bigger challenge is to see how it behaves on the live images.
Okay.
So either I can, as I showed, so I can select a coffee cup from the stored images and I can run the model on it, or I can click live and have the live camera model be running on the live camera. So if I were to point my camera on, there's a coffee cup on my table,
Mhm.
and if I were to point it, as you can see that it has started detecting the coffee cup, it is drawing a bounding box, and as the camera is moving, it is following the cup
Nice.
with segmentation and detection boxes.
Nice. And I can see how practical that is because you don't have to deploy the model to an actual device. You will ultimately do it, but during the training and validation phase, being able to do that directly from your workstation, that's pretty powerful. I love that.
So, of course, when the models are trained, you would like to run validation sequences on
Uh-huh.
that, on validation data set. So, there were validation sequences that I can go to validation and look at the charts over there and see how it is performing. But
Okay.
of course, as you saw, that looking at a live model running on the real object gives you much more confidence and feel. Uh, but
Yeah.
for more scientific oriented people, you can go to the validation results and be able to look at those.
Yeah. I would assume that was so when you say validation data set, that's basically a huge data set of images that have already been scored or tagged, and that the output should be this or that, and now you compare what the model has found in these images and with that validation data set, and you just like comparing the results to evaluate how good in this or that situation. So I guess, as you were saying, as a scientist or someone who already has in mind a specific set of environments or scenarios, you can say, hey, this is the kind of scenario this model will face. This is another one that it's more likely to face, and you can really evaluate how the different models are doing against that specific environment that you're aiming at.
Correct.
Excellent.
Um, and one thing I would like to highlight here that in addition to the very common recall, precision, MAPs, and histogram, true, false, false positive, false negatives, it also does the timing analysis. So if validation can be triggered on a PC, it
Mhm.
can be triggered on a cloud server, or it can be triggered on an edge device. So you can validate your model directly on the target that you want to run your model on.
Nice.
And then the timings do have they have a quite a significance because these are the timings representing the actual model that would be running on your device.
Okay.
So you can compare, as I said, that if you run different sessions, you can compare different validation training sessions
Mhm.
in a single screen. Like these are different training sets, charts superimposed on each other, so that we can compare which model performs how nicely.
Mhm.
Or these are training charts, or you can go to validation session here. validation sessions, and you can compare different validation. I can choose some different validation sessions
Okay.
and compare them. So that's the advantage of running them in parallel or one after the other. But
Nice.
you have the data for bunch of models simultaneously, and you can compare one to another.
That's pretty impressive, and the ability you have to not have to go with your own Excel spreadsheet and try to take the different line charts and comparing all of them manually is definitely huge. All of that provided to you in a matter of like 2-3 clicks in EdgeFirst Studio. That's brilliant.
And one new features that we are working on is to have an automated, even AI assisted comparison. So it will trigger, let's say, 50 training sessions, and then it will auto abort the ones that are converging less as compared to the others. And in the end, maybe you have out of the 50 you triggered, you have 8 models that are the candidate models, and then you
Yeah.
choose.
Yeah, because there would be no reason to waste your resources and money on training models that, anyways, will not be performing like you want or need. And so being able to interrupt them is a matter of like saving resources and money. I like that.
Yeah. So this is a simplistic model,
Mhm.
coffee cup training. And if I were to show you how much time it took for training, if we go there, see 42 minutes, 41 minutes, and these are trained on either Model Pack, which is our proprietary model, or on Ultralytics, YOLO V8.
Okay.
Uh, and most of them, some have run for 1 hour, but mostly 47 minutes,
And
46
and
minutes.
how big were the data sets you were training them against?
We can go to the data set and see how, like, actual stats of the data set. Go
Just to
to-
give people an idea of what to expect here.
So here it gives you the summary of the data set. It has about 1,400
Okay.
images, of which 1119 are in training set, 280 are in validation set, and it has how many annotations? So we can look at 1510 2D boxes
Okay.
and segmentation boxes.
Awesome. Awesome. And so the next step, once you have validated, would be to prepare the model for an export to a device, right?
Correct.
Okay.
So when you train a model, uh, as I said, that you could validate it on the target device. So there are the whole tool is API based. So you have scripts that you can run on your target device, and the validation, as the validation is going on the device, it syncs with the tool, EdgeFirst Studio, and it shows the progress.
Okay.
And that we can save for another session sometime.
Mhm.
Uh, and as you do that, you validate how good the model is doing on the device. But as the model matures during training, it generates artifacts which are already capable of running into the. So it quantizes the model
Okay.
for the hardware devices, and then you may have custom optimizers for particular devices. So we have optimizers for NXP hardware, NVIDIA hardwares. Those are available that you can simply optimize the deployment,
Mhm.
and then download from here, and there are scripts to upload to your device.
Okay.
Our platforms are designed in a way that you can just export the model. Even they have a web interface, a
Mhm.
small, very tiny web interface where you can upload the model file directly from here.
Nice, nice. And so you've shown here the example of that coffee cup, which is great. Actually, people will see if they go and try out EdgeFirst Studio, they have access to the data sets, and they have instructions as well in your documentation to go and play around with them. Do you have some examples of things that are closer to real life scenarios that you can tell us about?
Yeah. So when you sign up for EdgeFirst Studio, mine is a development environment, so there are many data sets already there, but you get this sample data set, sample project, pre-populated with your subscription. So you can play with playing cards, BDD, and they have trained models already in them. So this is an example of a BDD 100 model that detects cars and traffic signs. So we had a model that we trained a model on it and deployed on a mobile phone, and I took it out on my parking lot. And this is the video that I'm looking at. So as I am moving my mobile phone, it is detecting cars, and at some places you may be able to see that it detects fence signs that are on the fence. There's another one. So this is on the again on our parking lot, and it detects mostly car, but as I go forward, say it detects the traffic sign also. It is some parking warning that is here. So as you can see that the ability for it, the GUI framework is EdgeFirst Studio. So right in the EdgeFirst Studio, you can open a mobile view, and you can run your models. So this is running from the EdgeFirst Studio.
Nice.
GUI.
This is pretty powerful, once again. And everyone has that at hand, right? You don't need an actual device. You guys provide hardware, though, right?
Correct. So we have platforms that have integrated cameras up to 4K or 8K cameras, and those are a perfect way of either capturing the data and also for deploying the model and then running on the live stream. So that whole ecosystem for capturing, training, and then finally running and deploying cameras is already there.
That's pretty cool.
If I were to open another example, yeah, this is ocean cleanup, and since they have a huge amount of data, we have a segregated server for them, and they have images in order of few million.
Wow.
And there are, I will show some of the models that we've trained on their system. So these are their images, and this problem becomes much more tough because the object is very small compared to the amount of no significant data that is there. This is our background. It's not of interest to us, but the background has so much noise. So for a model to pick up very small objects from here becomes quite challenging. So these models have huge training time, and because the data set is huge and they are trained on 4K images. So, and now let me go to one of the experiments. So this was trained in 7 hours, but there are others that took a few days to run. And again, if I were to show the validation on these, you would appreciate that. So it gives the regular MAP and other common results, but here we can see that since these have a lot of classes in them, it gives a much more detail of how every class is performing and how the true positive and false positive change over different scores, confidence threshold, IOUs, and so on and so forth. Distribution of timing, which portion of the pipeline took most time to run. So these are examples. Since you mentioned our hardware, these images are captured from our own hardware, and then they are trained and then deployed back on the same hardware, and they are deployed on ships to capture objects in the sea and then to clean them up.
Awesome. So one more thing from you, Muid. So these are really great examples. I was mentioning the fact that some of them are available in trial mode. If someone wants to try out EdgeFirst Studio, we'll put a link down here for where to find it. And well, I hope we're going to get you on, on another episode soon, because there are a couple things, especially about your hardware, that I'm very interested when it comes to fusing different types of sensors. Camera is one. You have different types of cameras. You can have infrared and others. You have LiDAR that can eventually give you another dimension to the perception of your environment. And you guys have all of that. And when that all comes into place with Vision AI models in EdgeFirst Studio, that's really powerful. So I really hope we can have you on the IoT show again sometime soon, Muid, to discuss more of that Vision AI at the Edge topic.
Yeah, it was wonderful to talk to you and having me on your show. We have 3D and fusion examples that we could share on some other episode, and they are, I would say, even more interesting.
Definitely. Appreciate your time today, Muid. Everyone, thanks for tuning in.
Thanks a lot. Bye-bye.
Bye.